Friends, welcome to the second lecture in module 3. In this lecture we are going to talk about more details on fiber optic sensors. This lecture has additional reading reference, so this can be seen at the Procedure Technology Journal 26 524 529 for additional reading. Let us quickly see what are the principal differences of a fiber optic sensor, what are the various types of this sensor and how they are actually constructed or modified for the use of various measurements for monitoring in structural health monitoring process in buildings. Fiber optic sensors are actually contrast to electric sensors in many ways. Let us see in principle what are the differences. Fiber optic sensors use electromagnetic interference to read or measure data, whereas electric sensors use electric pulse to do the same job. Due to the low light attenuation of optical glass fibers, which are essentially used in fiber optic sensors, these sensors can be used in several kilometers long, whereas electric sensors have serious limitations in this front. Interestingly, classification of fiber optic sensors depends on various parameters. Namely, the light characteristics, that is their intensity, the wavelength, phase or polarization, etc. These characteristics are modulated by the parameters to be measured. Classification is also done whether light in the sensing segment is modified inside or outside the fiber. That is, they are called either intrinsic or extrinsic. They are also classified based on whether they are local, where they are quasi distributed, which is called fiber Bragg grating, that is FBG, or they are distributed sensors. Which is otherwise called Brillouin scattering distributed fiber optic sensors. They are also classified based on how are they installed. Generally, they are surface mounted, but they can be embedded also. So, now we have seen how these FOS sensors are classified based upon the light which is being used for measurements, whether the modification is happening inside or outside the fiber, whether they are local, quasi distributed or distributed sensors for the entire length of the member, whether they are embedded or surface mounted. Let us now see types of fiber optic sensors which are used for different applications in structural health monitoring. Let us talk about fiber optic sensor use in measurement of moisture ingression. Moisture ingression is one of the major problems in buildings. The most important task is it is very difficult to measure this data. That is, it is difficult to measure the source of, to identify the source of moisture ingression and its path of propagation, because this is actually a surfacial phenomenon. It spreads on the entire surface and makes the surface wet. So, once the surface is wetted, it is very difficult to locate from where the origin started. Fiber optic sensors can be used to identify, solve the location problems of moisture ingression. So, essentially the FOI sensors used for moisture ingression in principle consists of a swellable polymeric fiber optic sensor. This is used to measure distributed moisture formulation. This sensor works in combination with optical time domain reflectometer to determine the spatial location of moisture ingression. This measures the point of ingression. This measures, or I should say identifies the point of moisture ingression by attenuation principle. A typical sensor looks like this. Which consists of a protective layer of felt wick. This is a protective layer of felt wick. This consists of a connectivity between these two, which has an optical fiber embedded into it. This is the optical fiber, which is now connected to optical time domain reflectometer. The device consists of an optical fiber, as you see marked in red color, a polyvinyl alcohol hydrogen rod, which is embedded inside a protective felt. The device can sense the micro bending of fibers. Hydrogel has a capacity or a characteristic of swelling in the presence of water. That is why it is called hydrogel. The interesting property is it swells without dissolution, and this causes the optical fiber to undergo a micro bending. Now, the micro bending of the fiber causes or let us say interferes with attenuation of light, which is transmitted through the fiber. So, that is how this measures the location of moisture ingression. The second application which is commonly used in health monitoring related to relative humidity is fiber optic sensor used as single point relative humidity sensor. This sensor is made of polyimide coated fiber Bragg grating. It is actually a grating. Due to the wavelength, the encoded relative humidity readings are measured by the sensor. The FBG sensors are coated with polyimide coatings to protect them. Several such sensors can be used in parallel. To measure relative humidity. This device consists of fiber Bragg grating coated with polyimide, This coating acts as a hygroscopic coating that swells in the presence of water. Water vapor due to absorption of water molecules, and this causes strain in the FBG sensor, which actually depends on the applied relative humidity linearly. Now, by tracing the reflected Bragg wavelength, RH value of the location where the sensor is placed, can be measured. This is very useful in tropical locations where relative humidity can cause material degradation to a large extent. It is generally useful to plan preventive maintenance in case of monumental buildings.